So we were discussing about the multi-class classification using the artificial neural network, and we looked at the background theory required for that. All right, now let's look at a example, and let's try to build a neural network which actually classifies, which resolves this problem of classification, and we are going to see that we are going to use multiple classes. Okay, so this is the definition of our problem. Let us say I want to design a neural network which takes a binary image as an input and it classifies them uh, according to the number of 5 classes. Okay, so let me take an example over here. So example, the example we want to solve now is a binary image classification. So later on, this can be even extended to the handwriting digit classification as well. Okay, so for the timing, let us assume that right, we have images as input files. We give image as input. It's a binary image. So binary image in the sense it's the value of each pixel can be 0 or 1 only. Size can be anything, right? You can have 10 into 10, 20 to 20 or any size, doesn't matter. But for the time being, let's try to keep it as simple as possible. I'll show you what is our data set. So let us assume that I just want to classify these 5, right, digits. This is what is my idea. So first one is 1, 2, 3, 4, 5. So each of the class is a 5 into 5 pixel, right, image. So each data is a 5 into 5 pixel image, right? So they represent representing 0 to 5, right? So this is very clear, right? What is the size of my input now? Input size will be, so there are 5 classes, but each data is 5 into 5. So 25 values I give as input, correct? One input is 25 different values. For example, what will be the values like? So where I don't have, maybe that is right, you can try to represent that particular value as ones or zeros, right? You may have ones or zeros over there, right? So where you don't have a value, that is 0. So this is 1, 1, 0, 0. So 0, 0, 1, 0, 0, and so on. Wherever you have the dark color, I try to represent that as a 1 because there is some value over there. Other values are zeros. Okay, like this. Like this, your pattern will be given to the machine, right? In terms of various 5 into 5 data set for all of them. Okay, this is my idea now. I want to give various patterns so that it can classify. Now let's go ahead and apply the steps we studied in the previous section, right? What are the steps you need to follow? First, you need to decide what should be the neural network, its architecture, right? So I know that what is the uh, input layer size, right? So I'll write the ANN, artificial neural networks architecture, should be decided first, right? Now each of the image has how many values? 25 values, like 5 rows, 5 columns. So the input layer has 25 nodes, right? Input layer has 25 nodes. This is my first. Then how many output nodes you want? Output nodes should be equal to the number of classes, correct? So output layer is going to have 5 nodes, right? The previous example which we considered, that has only 3 nodes because 3 classes. Now 5 classes, so 5 nodes. All right, let's move further. Now should I use a hidden layer? Obviously I have to use now, because if you try without using the what you call hidden layer, right, what happens is, you see there are so much of inputs, right? From what you call 25 inputs, I have to decide 5 classes. It's actually a huge, right, responsibility for a neural network, huge job. Without connecting any of the what you call hidden layers, if you don't use it, it's not going to classify. Previous case I told hidden layer is not required because 2 inputs, 3 classes, right? Inputs are less, classes are more. Now you see the reverse, 25 inputs, 5 classes, right? Can you see the difference? So I need the hidden layer, right? Again, you can like you can make an assumption, like since the it's a 5 times larger inputs compared to the outputs, right? Maybe I'll take that 5 as a reference number and multiply by 10, so 50 maybe. I can start with that. Okay, so there is one hidden layer with the 50. Okay, so output 5 nodes, comma, what is the activation function I'm supposed to use? The softmax. Softmax activation. And right, the hidden layer, right? So there is how many nodes I told? I think we can start with the 50. Okay, 50 nodes. And you don't change the activation function of the hidden layer. It's still going to be sigmoid. Sigmoid activation. So let's try to look at what kind of architecture, right, that we are going to use now. So again, this is just a pictorial representation. So the actual one looks pretty complicated, but we are trying to make this as simple as possible. Okay, so this is what we are looking for, right? So there are 25 input nodes, 50 hidden and 5 output. So each of the output will respond accordingly which class it is. Like if the input data belongs to class 1, first neuron will be providing you an output as 1, others are zeros, and so on. Second one will fire for 2, third one will fire for 3, fourth one for 4, and fifth one for 5. Others will remain 0 when you do this. So now my intention is to uh, give the uh, write a function which classifies this. All right, I have to update the weights according to my function, right? So let's try to write a code. Let's jump onto the MATLAB window. And now let's go to a multi-class code. So I think I don't need any of them. Okay, I'll go to the edit part. And let me give a name. The function is a multi-class. So the function name I'm going to give is multi-class. So when I press enter, a new program will open up in the editor window and its name comes to be the same as multi-class. So this is a function. So the function should be written in this way. So you mention what are the outputs you are expecting, W1 and W2. Okay, so these are the two outputs. So W1, W2 is equal to, give the same name as the file, Multiclass, and just mention what are the inputs you are going to give, right? So that is W1, W2, the input vector X and the desired vector D. Okay, so this is the function. So start with the definition of alpha. So equal to, let's give 0.9 now. And what are the number of classes? So n is equal to, in this case, 5, right? We have 5 classes. Then for I is equal to 1 to n. So for all those 5 classes, I am supposed to do x is equal to, right? You see, now it's not a row vector, it's actually a matrix, right? So each input, digit 1 is a matrix, digit 2 is a 5 into 5 matrix, 3 is also same, 4 is also same, and even 5 is, the data corresponding to the 5 is also a 5 into 5 matrix. But if you remember, I have to convert this 5 into 5 into a single vector, because all of them will go as directly input to all the 25 corresponding input neurons, right? So I'm not using the direct similar steps I used earlier, because previously you used to give the vector directly, but now it is not a vector, it's a matrix, right? I have to convert the matrix into a vector. So how to do that, right? Which is the function that you can use to reshape the matrix, because it's a matrix, I want to convert into a reshaped, right? So this is reshape itself is the name, right? So what you want to do now is, the x is the variable name, right? You try to keep okay, all the rows, all the columns, and I would like to write the I here. Okay, I, right, irrespective of whatever you have, all the rows, all the columns, comma, whatever is the ith value here. This you want to convert into, how many rows you want? 25. How many columns you want? 1. You see, you are converting x into 25 rows, 1 column, right? Vector. That is what is this x. Then d, the desired, sorry, I'll write a smaller value of d. So d is equal to capital D of, right, this is the jth value, comma, all the columns. Okay, we'll take a transpose to match the requirement. Okay, not j, sorry, it's I. We use indexing as I, so I'm using this. Now, you know that x input and the desired value, calculate the outputs first. So V1, right, should be equal to, how do you calculate? This is weight into the x, right? Use the V1 to calculate the Y1. How do you calculate Y1? It is simply the sigmoid function, right? So my sigmoid of the V1, isn't it? Next, once you have this, calculate output the output. So that is V is equal to the second weight multiplied by the Y1. And once you have this value, you can calculate the final output. Y is equal to, once again, my sigmoid. Oh, okay. So you see here, this is the output layer, right? So you cannot use the my sigmoid, because you have to define a new function now that is called as the softmax, isn't it? Because you see, output layer we have to change, right? So I'll define my, I have to use a new function. Okay, I'll call this as my softmax of, anyway, I have not defined this yet, I'll define it later. So but anyway, I can use it before I define. So this is how it will be used. My softmax is yet to be defined. So once you have a y value, calculate e, right? The error is nothing but the desired value minus the output. Once you have the y value, you can assume this to be the delta of your output layer, that is E itself, right, according to the cost function, which is entropy based. All right, so we know this. Then let's calculate the error 1 of the layer which is previous to this. So E1 is equal to, how do you do that? This is the W2 transpose should be multiplied with the input to that, right? So this has to be, sorry, W into delta of that. So I calculate this, then calculate delta 1, that is equal to the, you are using the sigmoid, so the derivative of the sigmoid is nothing but the output, that is y1 dot star 1 minus y1, okay, once again dot star the error of that layer, that is E1. So you use y1, 1 minus y1 and E1 to calculate the value of delta 1. So once you have the delta 1, right, I can update the dw, should be equal to, apply the same rule which we were using in the previous session. So that is alpha into the delta 1 into, right, it is the input taken in transpose, that is dw1. So w1 is equal to w1 plus dw1. We got this. Similarly, go for dw2 is equal to, how do you calculate dw2? Once again, alpha multiplied with the delta, multiply that with the, right, the y1, right, just to match, we take a transpose, okay, then update w2 is equal to w2 plus dw2. So that updates the weights, w2, and it's done. So I have to, I think we started with a for loop just now, so I'll end the for loop here and I end the function over here. I'll just save it. Okay, so this is a function, and I think in this function I have used what is called as a softmax. So let me write that. This is edit my softmax. Let me just verify the name given. So this is my softmax and I'm matching to this. Okay, let me just enter. So it opens up a new thing. So I have to, this is a function, so function, I'm expecting an output, say y is equal to, give the name my softmax. What are the inputs? You pass a variable x to this. Okay, so in this I'll create a variable called the exponential term. What is the exponential? E to the power x, right? It is simply exp of x. You see, this x will be an array, right? So x will be an array, ex will be e to the power x of every value. If you remember, if you pass a matrix as input to the e to the power exponential variable, it retains the shape and calculates the e to the power of each and every element of that matrix. So that's what is going to happen now. So I just have to return a value y is equal to, right, it is simply ex, right, and I want to divide this ex by, right, the sum. Okay, sum of ex, and end this. So softmax is done. So multi-class training has been done. Now I just have to test this multi-class, whatever we have written. Okay, so all right, so let me create a new file, edit. I'll call it as test multiclass. So I'm going to create a new file, and let's start with the clearing, closing, and clearing the command window. All right, so we need to define the x as a variable. So x is equal to, right, you know the size, right? I'll allocate zeros of 5 rows, 5 columns, 5 such data. So 5 into 5 into 5. If you see, it's a 3-dimensional what you call data, right? In which the first page of this 3-dimensional data will be the data corresponding to the number 1. Okay, let me show you how to enter, right? We know that how to create the what you call 3-dimensional data. So first let me create the first data. So that is x of all the rows, all the columns in the first page, right, is equal to, define this. You see, I want to create a 1 now. So 1 according to my data, you'll see the 1 now. Okay, I'll just show you how to write that. So 0, then I think 1 1 0 0, followed by, then the next one should be 0 0 1 0 0. The third row should be the same, 0 0 1 0 0. Even the fourth line is going to remain same, 0 0. You can see a 1 building up now, 0 0. And the last row is, right, 0 1 1 1 0. So you can see a 1 which is written here, right, in terms of the ones, these two ones, then the one which is present in this, the next one, and the next row, right, and the last 3 ones, they actually construct a 1 for us. So that's why this is the first one. Okay, then the same thing, x of all the rows, all the columns, and the second page, right? Here I am supposed to write the data corresponding to number 2, right? So how do you represent a 2 over here? Let me try to write that. So I'll try to put 1 1 1 1 0. Then the second row will have 0 0 0 0 1. Okay. The third row I want to put 0 1 1 1 0. Let's come to the fourth one. Fourth row is 1 followed by 0 0 0 0. Okay, let me come to the fifth one. Fifth row, all ones, 4 5. Okay, this looks like 2 for you, right? All right, right. So that's how I defined the digit 2, right? X of all the rows, all the column, third page. Now I am supposed to enter the data corresponding to 3. Okay, so this is, I try to write a 3 now, 1 1 1 1 0. Then 1 2 3, say this is 1, so I want to create a 3. So these values are supposed to be 1 now, so I'll write like 1 1 1 followed by 0. Then say 0 0 0 0 and 1 followed by say 1 1 1 1 and a 0. Okay, this looks like 3, right? Okay, then this is x of 3. I have to create all the 5. So x of all the rows, all the columns, and the fourth page should look like this. I'm trying to create number 4 now. So 0 0 0 1 0, and then I'll write say 0 0 1 1 0, 0 1 0 1 0, and the fourth one I'm trying to write, say, okay, this has to be 1 1 1 1 1, and the last one, let's make it like 0 0 0 1 0. Okay, the all the ones here looks like 4 for us. Okay, then trying to write the fifth digit now. So all the rows, all the columns, and the fifth one is equal to, so let me try to create a 5. So 1 1 1 1 0 0. Okay, looks like we have our data set ready. Okay, now I just want to create my desired data as well, right? So what is the desired class value? So D should be equal to, what's the size? We know that it is a 5 into 5, right? So first class should be 1 followed by 4 zeros. This is the class 1. Similarly, right, for the desired class 2, this should be 0 followed by 1 0 0 0. Then the third class 0 0 1 0 0. Then the fourth class 0 0 0 1 0, followed by the fifth class 0 0 0 0 1. So this is the desired class vector. All right, so once we have that, now you define the random weights. Okay, so say w1 is equal to, maybe I'll bring a random thing into picture, say 2.5 into random. Now decide what is the size, right? So there are 25 input neurons. They are connected to 50 neurons in the next one, correct? So this has to be 50 rows and 25 columns, right? You see the size of the weights for the first layer, right? So I'll subtract, maybe minus 1.5. This brings into a random case. Also define W2 is equal to, say, 3.5 into random. Decide the size. Now you see how many layers it is connecting. It is connecting 5 neurons at the output, right? So coming from 50 inputs. So for an output layer, the number of inputs are 50 because hidden layer has 50 neurons, correct? So this has to be, output is 5 and input is size 50, right? So that's the random size we are creating. So minus 2.25 maybe. All right, it creates a random weight vectors. All right, so start with the epochs, right? So say for epochs equal to Maybe I'll start with 1000. Let's see what's going to happen after 1000 epochs. If it is not sufficient, we'll increase. All right. So this is W1 comma W2 being equal to call the function that is multiclass. What you are passing? You are passing the weights W1. You are passing W2. You are also going to pass the X and D. So update the weights. This is the training process. Once it is done, end the for loop. So many times you are training. That's all. Okay. Once it is done, now you are going for a testing phase. So n is equal to 5. 5 inputs you are going to give, and say start with the for loop. For say j is equal to 1 to n. Do the following, right? So whatever data input data you have, you convert that into the x vector. So small x is equal to what you are supposed to do. You have to reshape because it is a 5 into 5 matrix, right? So reshape of the capital X of all the rows, all the columns, and say jth page, because every time j is the controller, which input is you are trying to give, like j is 1 means first digit, j2 means second digit, and so on, right? So I'm trying to keep track of that. So right, this comma convert this into 25 rows and 1 column vector. So that is x, right? Then calculate a v1. v1 is equal to the w1 into x, right? Convert this v1 into the partial output of the hidden layer, that is y1, right? y1 is nothing but which activation function? This is softmax of, right, v1. Apply that, you got an output. So once you have v1, calculate partial output of the output layer. So v is equal to w2 multiplied with the previous output, that is y1. And once you have this y1 with the v with us, you can calculate the final output y. But since, right, this is a multi-class classification, you cannot use a softmax. You my sigmoid, my mistake, sorry, you cannot use a sigmoid, right? So it's not a softmax. The hidden layers, they are still sigmoid, okay? And only the final output will be softmax. So the function name which we have written is my softmax, okay? My softmax of v. Apply that and calculate the output y. Okay, I think I can write y of j itself, or let's write y itself. Let's see what's going to happen later on. We can make a changes. Okay, so this is how the y is being displayed. So let me make one thing here. So I'll create an answer here, right? So class is equal to, I'll create a null. All right, then I do this. I'll add up a line over here. Class is equal to, inside this I'll append class space y. So y gets added to the right side of your class every time you run. And finally, I'll just visualize what is that class. Only this is sufficient. Okay, I'm trying just 1000 times. See, the epochs are just like this. So you can see this is first class is like 1 followed by 4 zeros below that, right? So for the second class, you see, right, zeros, this is close to 1 and followed by all zeros. There is small error, right? You are not getting exact ones and zeros, but definitely this is close, right? Now let me increase the number of epochs to 10,000 and see whether I'm going to get a proper answer. Yes, you see, by just having 10,000 epochs of this data, right, we are getting a very close answer. right? And this is pretty much whatever is the required answer, you are getting this, right? So you can by using this example, it is very clear that how can you write your own code to classify some realistic data, right? uh, like an image, right? You can give as input, you can define the number of classes, define your own kind of network, and you can actually, right, make the classifier to work to classify multiple classes, right? So now you can actually make some changes in the code so that you can change the number of hidden layers, you can change the weights, and also you can try to implement something your own, right? Maybe some other classification. All right, so you can definitely build, and that becomes a something like a mini project for you.